Hello, this is for my 2-day College Algebra Co-Rec Exam 5 review. All right, we're going to start off on number 1. Number 1 is a 2x2 system that we're solving. It is perfect for substitution. So I'm going to start off by saying x is equal to this little block right there. That means that everywhere in the other equation, everywhere there's an x, we're going to substitute in that little block. So we get 6y plus 8 equals x, but now I know that x is equal to 4y minus 2. We'll start, again, the parentheses are just to show that I plugged in case there's ever anything to distribute. It helps me not to forget. Not necessary on this one, but I showed them anyway. I'm going to start by moving the y's back over to the left, the constants over to the right. So we end up with 2y equals negative 10, or my y is equal to negative 5. With the y value of negative 5, that means there's a unique solution. So I'm going to solve for the x that goes with them by plugging back into that little block. It says x is equal to 4 times y, which we know is negative 5, minus 2. That is negative 20 minus 2, which gives us negative 22. For number 2, and again, pause the video or back up whenever you need to. On this second one is also a linear equation. I'm looking at the 3 and x, and I'm thinking 3x and 4x, thinking 12. But here I'm thinking I could just multiply the second equation through by 2 and get the y's to cancel. So I'm going to go that route. Now, the first equation didn't require anything, so I'm just going to bring him down. The second equation I'm multiplying through by 2, so I get 8x plus 2y equals 16. After combining, I do end up with 11 x's. My y's cancel, and negative 5 and 16 add up to 11. After dividing both sides by 11, we get an x of 1. With an x of 1, there's also a y value that I'm going to need. On this one, I use the addition method, so I'm going to plug into, I think, the second equation to solve for my corresponding y value. I have 4x, which I happen to know is 1, plus y equals 8. That's 4 plus y equals 8. After moving the 4 over to the other side, we get a y value of 4. On number 3, oops, went up too far. On number 3, it looks like, on number 3, looks like I get to use the addition method again. For 4 and 2, 5 and 3, I'm looking at the second equation and thinking, hey, I can cancel the x's out pretty easily by multiplying the second equation through by a negative 2. What if I didn't notice and I made 8x and negative 8x? Still going to work. I'm going to copy the first equation down. It didn't require any changes. The second equation I'm going to multiply through by negative 2. I'm going to get a negative 4x plus 6y equals negative 14. I'm going to add the x's together. They cancel. That's what I wanted to happen. I get 11y is equal to negative 11. After dividing both sides by 11, we're going to get a y of negative 1. Well, with a y of negative 1, that means that there is an x value I need to find. So I'm going to go back to the original equations, and I think I'm going to pick the first one. Everything's positive. I like that. And solve for x. 4x plus 5 times y, which is negative 1, equals 3. So we get 4x minus 5 equals 3. 4x will be equal to 8, or after dividing both sides by 4, you're going to get an x of 2. Now, make sure that you study the lecture examples, because I didn't see any infinite solutions on this review, but that's still an option for us. Number 4. Now we're on our 3x3 systems. And we got the perfect x right on top there. I'm going to use that first equation as a pivot to eliminate the x values in the second and third rows. So since the first equation is a pivot, I'm going to write it down because pivots do not change. Now I'm going to multiply my pivot first by a negative 3 to eliminate the x's in the second row. The pivot multiplied by negative 3 is going to look like negative 3x minus 3y minus 3z is equal to negative 18. The second equation didn't require any changes, So I'm going to go ahead and just bring it over, and then I'm going to add them together. The x's cancel, that's what I wanted to happen. I get y minus 10z equals negative 17. To eliminate the x value in the third equation, I'm going to multiply my pivot through by negative 2 and add it to the third equation. And it's going to look like this. Negative 2x minus 2y minus 2z is equal to negative 12. The third equation didn't require any changes, so I'm just going to copy it over and combine. The x's cancel. I get negative 3y plus z equals negative 7. Now I'm going to use the second equation as a pivot and use it as a tool to eliminate the y's in the third row. Because the first and second equations are pivots, I'm going to copy them down because pivots do not change. Now, in order to eliminate the negative 3y in the third row, I'm going to multiply my pivot equation by 3. Then I'm going to show it in the margin. It's going to look like 3y minus 30z is equal to negative 51. The third equation didn't require any changes, so I'm going to go ahead and bring it over. The y's cancel. I get negative 29z is equal to negative 58. We've got that nice triangular form. Oops, I missed the z on the left-hand side. That's not nice. So I'm able to now solve. I'm going to start with the third equation. Third equation says negative 29z is equal to negative 58. After dividing both sides by a negative 29, I get a z of 2. But remember, all of our answers are three-dimensional, so if our z is 2, I still have an x and a y that I need to look for. I'm going to back up to the second equation and solve him for y. Y minus 10z, which I happen to know is 2, is equal to negative 17. I get y minus 20 is equal to negative 17, or y will be equal to 3 when I move the negative 20 over. Now I'll use the first equation to solve for x. We get x plus y, which I know is 3, plus z, which I know is 2, equals 6. That's x plus 5 is 6, or my x value is 1. Remember, all of these systems that have points for answers can be checked by plugging back into the original equation. Now here is a 2 by 3, guaranteed that's going to be an infinite solution. And sorry about the order on those. I'm going to start by letting the second equation be my pivot, or I could rewrite it, I guess, but I'm going to use it as a tool to eliminate the x in the third row. Even though I know it's an infinite solution, I still have to do that step, don't I? And actually, let me behave and do it in the right order. I'm going to rewrite x plus 2y minus z is 4, and 2x plus 3y minus 5z is equal to 15. Now I'm going to use that first equation as a pivot to eliminate the 2x in the second row. So let's see, I think I'm going to multiply him by negative 2 in order to eliminate the 2x in the second row. But first, because the first equation is a pivot, he doesn't change, so I'm going to copy him down. And in the margin, I'm going to do the multiplication of negative 2 into the first equation. That's negative 2x minus 4y plus 2z is equal to negative 8. The second equation didn't require any changes, so I'm just going to bring it over and combine. The x's cancel. I end up with a negative y minus 3z is equal to 7. That is my new and improved second equation. But I know that with two equations with 3 unknowns, that's an infinite solution. I get half credit for writing those 2 words down. With an infinite solution, z gets to be himself. I'm going to solve the second equation for y in order to get the y variable. That says negative y minus 3z is equal to 7. That's negative y is equal to 3z plus 7. I'm going to divide every piece by -1. So I get y is equal to -3z minus 7. That's my y value. To get the x value, I'll solve the first equation for x. X plus 2 times y, which I happen to know is -3z minus 7, minus z equals 4. That's x minus 6z minus 14 minus z equals 4. I'm going to combine the z terms. That's x minus 7z. I'm going to go ahead and move the 14 over. Equals 18. So my x value will be 7z plus 18. All right, we'll pick up in the next video.